Is your RV's AC either turning on but not cooling, or humming but not actually turning on? Either way, in this video, I'm gonna show you how to diagnose what's wrong with your air conditioner without having to call a tech. This video is the last part of a 5-part series where I'm walking RVers through the 10 most common calls that I get as a tech, and revealing how anyone can solve these problems themselves with just a multimeter. My name is Emily, and this is RV Repair Woman. If you already know how to use your multimeter, jump to here if your AC is turning on but not cooling, or here if your AC is humming but not turning on. For the rest of you that have been learning about their multimeter along with me, let's jump into it. So in the last couple of videos, we went over the voltage tests for both AC and DC, continuity and resistance. So today we're gonna go over the amps test. While we tend to use the voltage test to tell us where electricity is in a circuit, we tend to use the amperage test to tell us how hard individual components in the circuit are working. So if we remember back to the voltage test, there's going to be a number that we expect to see. If we're looking at DC volts, that number is probably around 12.5. And if we're looking at AC volts, the number's probably around 120. So we have an expected value and we compare it to the value that we actually see in real life. When it comes to amperage, we're gonna get our expected value from a tech sheet that is somewhere on the appliance that we're testing. So I can pull up the tech sheet for your specific appliance and then compare the amperage reading that we should be seeing for various components to what I'm seeing in real life. If the amperage reading we get in real life is significantly different than what the tech sheet says it should be, then we know that something is wrong with that component and we can act from there. And just like voltage, there is an AC amps test and a DC amps test. In RVs, there just aren't a ton of examples for where you might use the DC amps test. I know I'm gonna get people in the comments being like, what about this? And yes, you're right. There are some places you would use it, but in general, the AC amps test is used far more by techs than the DC amps test. Remember how I told you in previous videos that the DC side of things tends to be the brain, while the AC side of things, apparently I'm Jamaican, while the AC side of things tends to be more of the brawn of the situation. Because the amperage test is the test that tells us how hard things are working, we tend to care about it more on the AC side of things when we're looking at the brawny AC power. I hope that makes sense. So I'm gonna concentrate on the AC amps test today. So how do we test for AC amps with our multimeter? Well, unfortunately, that super simple, cheap $7 Harbor Freight meter that has been able to get you all the way up to this point in this challenge doesn't have an AC amps test. It's where we start getting to the limits of the $7 meter. It only has a DC amperage test. If you end up in some niche scenario where you do want to test for DC amps with this meter, you're going to be looking for this section labeled DCA for DC amps. And again, we have to tell this meter, because it's not very sophisticated, roughly what range of amps we're expecting to see. If you're on this super cheap meter like this, setting it to the largest setting that it has is probably gonna be your best bet. But on my Klein CL800, I just turn the dial to the A setting and then use the orange button to toggle between AC amps and DC amps. So now that our meter is set up, how do we actually test for amperage? Running an amperage test with your probes is actually something that I don't do that often, if at all, as a tech. I can maybe think of like 2 times as a tech that I've ever needed to do this. Unlike with the voltage test, where we could most of the time just leave the circuit alone and then just poke and prod into it with our probes to learn where the electricity was. With the amperage test, because we're trying to read the current going through the wire, we actually have to have our meter in line with the circuit. So it actually has to become part of the circuit. If we think of our circuit as like a whole bunch of people holding hands, if we were testing the voltage across one person, we could just put our probes here and here and measure the voltage across one person. This is a metaphor, stick with me. In order to read amperage, on the other hand, we would need two people to stop holding hands, and we would need our meter to go in between the two people. And then we could read the amperage going through the whole line of people. What this looks like in real life is, if you wanted to do an amperage reading with your probes, is you would have to disconnect some part of the circuit and then put one probe on the terminal that you just disconnected from, and your other probe on the thing that you just disconnected. You can think of it as we're recreating the connection that we just disconnected with our meter. But as I hope that you're kind of seeing here, in order to get the probes where they need to be, it can be really difficult to do safely without shocking yourself, because we do need to have the power going when we're doing this test. And you're gonna run into scenarios like this 9-pin connector on Coleman Mach air conditioners, where you have like 9 wires all going into one clip, and there isn't really a great way to disconnect just one wire from that whole setup. This is why I basically never run an amperage test with my probes. It's honestly just a pain in the butt. When I run amperage tests, I use my amp clamp. To use my amp clamp, all I need to do is set the meter to amps, either DC, AC, doesn't matter. Find the wire that I want to test the amperage for, and then just wrap the amp clamp around it. And then the meter is going to use this really cool property about electricity. When electricity goes through a wire, it actually creates an electromagnetic field, and the meter can detect that electromagnetic field and do some backwards math to figure out what the current is going through the wire. It's pretty cool. If you remember from physics, the like right-hand rule, that was that electromagnetic field and amperage. It all comes back, guys. We all should have paid attention in high school physics. This is so much more useful to me because I don't need to disrupt the circuit. I don't need to unplug things. I can leave everything just the way it is, wrap my clamp around a wire, and be on my merry way. And remember, if you're madly taking notes, you can go to rvrepairwoman.com/5000 and get my free guide that's gonna walk you through not only all of these settings on your multimeter that we've been going through in this series, but also walk you through step by step how to do the 10 calls that we've been going through in the series. And you can have that for you to look over and use as a cheat sheet whenever you'd like. Again, you can get that at rvrepairwoman.com/5000. You got this. Speaking of calls, hello? Please come out and help me. This air conditioner isn't cooling at all. Isn't there some kind of easy test you can run that would tell me whether or not it needed a recharge or it had a bad compressor? We've got this. This is a super fun and easy test that anyone can do with their multimeter as long as it has an amp clamp. Head to your rooftop AC and find your compressor. Locate the black wire coming off of the compressor if you're on a Coleman Mach air conditioner, or the blue wire coming off of the air conditioner if you're on a Dometic. While the air conditioner is running, set your meter to AC amps and wrap your amp clamp around the specified wire. You should get a reading of some sort. Now, somewhere on the rooftop unit should be a big sticker. It's usually about like yay big. It's gonna have a whole bunch of numbers and some technical information about your air conditioner. What you're looking for now is the RLA. Do not get confused by the LRA, that's a different number. We're then gonna take that RLA number and adjust it either up or down depending on what the temperature is outside. Use this table if you're on a Coleman air conditioner, or this table if you're on a Dometic air conditioner. Both of those tables are in that guide if you want to download them. For the Coleman Mach air conditioner, we're going to adjust the RLA number either up or down 1 amp for every 5 degrees off of 95 it is outside. And for the Dometic, we'll go up or down 1 amp for every 10 degrees we're off of 95 outside. Basically, your air conditioner should be working harder if it's hotter outside and should be working easier if it's cooler outside. And that's what we're adjusting for now. So compare the reading that you got on your meter to this adjusted RLA number that we just calculated. If the reading that you got is drastically higher than the adjusted RLA that you just calculated, then there's a good chance you have a bad compressor. And you can double check that with the test that we learned about in the resistance video. If, on the other hand, the reading that you got was drastically lower than the adjusted RLA reading, that means that you have a refrigerant leak. Unfortunately, neither of these problems are solvable. We don't really change out compressors on air conditioners. They're hard piped in, and there isn't a great way to recharge RV air conditioners. There's not a port to pour more refrigerant in. So no matter what, if the reading that you got is drastically different from that adjusted RLA reading, you're looking at a new air conditioner. But you at least diagnose the problem yourself. You're killing it. Most mobile techs charge for both the diag and the install of a new air conditioner. So even if you can't do that AC install yourself, you've saved yourself money by doing the diag yourself. You got this. Hello? You gotta help me. This dang air conditioner keeps making this weird humming noise and won't actually turn on. I'm on my way. If your RV's AC is making this aggressive humming noise when you go to turn it on, but it won't actually start up, that is classic bad capacitor. Here's how to double check and find out using your AC amperage test. Go back to that same wire that we talked about for the last call. The blue wire coming off of the compressor for Dometic, or the black wire coming off of the compressor for Coleman. Wrap your amp clamp around that wire while the air conditioner is making that aggressive humming noise. If the reading is going all over the place, it looks like it's trying to ramp up and then falls back down to 0, and then tries to ramp up and then falls back down to 0. That is classic bad capacitor. The capacitor's job is just to provide some extra oomph to help get the air conditioner going on startup. But if the capacitor doesn't have enough juice in it, it's not going to be able to help the air conditioner get over that hump that it takes to start up the unit. So what you're seeing on your meter is the capacitor trying to ramp up to start the air conditioner and not quite making it and coming back down. And then trying again and not quite making it and coming back down. If you would like another video explaining how to safely discharge and replace your capacitor, if that's not something you already know about, let me know in the comments and I'll make a whole video outside of this series just about that. But at the very least, right now, you have definitely diagnosed what is wrong with your air conditioner all by yourself, just using this AC amperage test. And if you've been following me through this whole series, you now know how to run your DC voltage test, your AC voltage test, continuity, resistance, and amperage on your multimeter. You now know how to solve 10 of the most common calls that I get as an RV tech. And you now have the basics behind what every RV tech is doing when they come out to try to diagnose something in your RV. So what's next? If you would like to know step by step how to diagnose every appliance in your RV, head on over to rvrepairwoman.com/RV Academy. Starting in July, I'm gonna be putting on a live 4-week-long class where I'm gonna walk you through step by step how to diagnose every part of your tanked water heater, absorption style fridge, furnace, or air conditioner. You're basically gonna learn in 1 month how to become your own personal RV repair tech. We'll meet every Monday live to go over the appliance of the week. And you can ask your questions real time via chat. And if you can't make Mondays, I totally get it. I had to pick a day, so I picked Monday. Don't worry, with your sign up, you get access to 6 months worth of replays. So you can watch the replays at your own time and at your own pace, over and over again to your heart's content. And you'll have access to a private community of just me and the other RVers going through this course. So you can ask your questions there that come up as you're going through the replays. And you can get them answered either by me or by the other awesome people that are taking the course alongside you. There's also going to be a ton of other awesome bonuses that I don't have time to list out here. I don't know when I'll get the chance to run a course like this again. I'm honestly so busy as a tech, and the only reason I've been able to find time to do this now is because I've ramped back my business just a little bit because it's so hot outside right now. But I don't know if I'll have time to do that again in the future. So if this is something you're interested in, now is the time to sign up. Again, you can find out more about this at rvrepairwoman.com/RV Academy. Check it out, learn more about it, see if it's the right fit for you. I'm super excited to meet some more die-hard RVers who are ready to take real ownership over their RV and be ready to handle anything their RV can throw at them. I'd love to see you there.